Alright, so today we're using the spectrophotometer, and you can get qualitative and quantitative data from the spectrophotometer. The qualitative data you can get is you'll be able to find the lambda max, and also you'll be able to see what wavelength you'll find the lambda max. And then the quantitative data is how high is the absorbance of different wavelengths, such as the lambda max. And the lambda max is how high. The lambda max is the wavelength at which a substance has its highest photon absorbance. And also we need to scan across every wavelength. That way we can differentiate and find the lambda max, which is, like I said, is the peak wavelength where it's the highest absorbance.
Beer-Lambert's law is the linear relation between concentration and absorbance. If you fail to zero the spectrophotometer, it will skew the results because zeroing negates the effects of the water molecules. In order to calculate Beer-Lambert's law, you multiply Epsom's value times molar concentration times optical path length, and that will give you absorbance.
And here's the visual image of the equation. See, the absorbance equals to the Epsom's value times the molar concentration times the optical path length.
Here we are putting some of our stock solution into a cuvette just up to the line, not over. And we're going to do this same thing for our first dilution, our second dilution, our third dilution. Like I said, we're just filling up to just barely under the line, trying not to go over it. When using the spectrophotometer, you want to wipe down both sides of your cuvette, and you're going to put the recently wiped sides in line with the beam in the spectrophotometer. Okay, so our stock solution's in there. We closed it up. Now we're going to zero it out and scan it. We're scanning the absorbance of our stock solution first. Now we're opening the spectrophotometer, taking it out.
This one is just for the blend, correct?
Is that the end of that video?
And here are our measured absorbances for our dilutions. Here we are wiping down one of our dilutions here, wiping it down both sides, like I said, putting it in the spectrophotometer with the wiped sides in the beam. It's in there, closing the spectrophotometer. Now we're scanning the absorbance of the sample. It's reading, like I said, and you can see it's zeroed out before. See, it was zero before we started scanning.
Got a video taking it out.
Okay, so we're done scanning. Now we're going to open the spectrophotometer and take our sample out. Now we are closing the spectrophotometer and wiping it down so another group can use it. And here's a calibration curve and a chart of our average absorbances. And as you can see, there's a linear relationship between absorbance and concentration. Absorbances.
Now we're cleaning up.
Always make sure when you're finishing a lab to make sure you clean your area. Pour out any unused fluid that can go down the sink, and make sure just simply wipe down your lab table when you're finished.